in this demo, I want to go ahead and take a look at uh, ES6 object-oriented programming in JavaScript. So what we're really looking at now is instead of using prototypal inheritance in JavaScript, we can now use kind of a more traditional C-style approach or kind of more traditional Java approach to object-oriented programming. Under the covers, we're still dealing with prototypal inheritance, but I think some of the syntax becomes a little easier based on the new modern ES6 syntax. So I'm going to go ahead and start with an HTML page, and I'm going to title this Object-Oriented Programming. And I'm going to have a reference to a JavaScript file called oo.js. And I'm just going to go ahead and save this on my desktop in a new folder called oo, and the file name is index.html. And then I want to create that JavaScript file, so oo.js. And the first thing I'm going to do is going to set up an onload event equal to init, and that init method will allow us to kind of play around with the classes that we're going to create. So I'm going to go ahead and create that init method. So create my new function, and the first thing I want to do is I want to create a class definition. And with traditional JavaScript, so before ES6, traditionally we'd create a class definition using function syntax. So for instance, I might create an animal class. So I'd create an animal class. And you'll notice the use of this uppercase letter, and that's a convention in JavaScript indicating to me that I want to use that function as a constructor. Okay, so the way I'm going to handle this is I'm going to have an animal class, and each animal is going to have a weight and a speed and measured in miles per hour that'll indicate how fast they can run. So a weight and miles per hour, which will be their speed. And what's going to happen is those two pieces of data are going to get passed in every time we create an instance of an animal, and then we'll be able to attach those to the current instance to say that the animal has a certain weight and the animal has a certain speed that's measured in the miles per hour passed in. Okay, and then because we've done this, we should be able to get information about this animal. We should be able to get their weight and their speed. So what I want to do is I want to have a description for the animal. So I'm going to take the animal and I'm going to say that the prototype has a description method. It's equal to some function definition, and I could use modern function syntax here, but I'm going to avoid doing that. And the reason I'm going to avoid doing that is because it disallows me. It doesn't allow me to use the this operator or keyword to refer to the current instance of my animal, and I want to be able to do that. So I have this description, and all I'm going to do is I'm going to return my weight is, and then I'll use this dot weight, and my speed is this dot speed miles per hour. Okay, so I'm going to have that return value. So this function is going to be available to all instances of an animal. So using existing JavaScript syntax, I can create animals. So let's say I create a giraffe equal to a new animal, and the giraffe's going to be 1,800 pounds and can run 40 miles an hour. And then I'll create another animal. The second animal will be a dog. So it's going to be a new animal that weighs 50 pounds and runs 35 miles an hour. Okay, and then I want to use my description function. So I'm just going to do a console.log of giraffe.description. It's a function, so I'm going to use the beginning and ending parentheses. And same thing with the dog. I want the dog.description. Okay, and the idea here is that I should be able to open this up in a browser. Okay, and then I want to open up the developer tools and look at the console, and you'll notice that I'm seeing the information that I had passed in. So for the giraffe, the weight's 1,800 pounds and the speed's 40 miles per hour. For the dog, the weight's 50 and the speed's 35 miles per hour. Okay, so we're able to have kind of object-oriented programming without using class definitions and things like that that we're comfortable with from our object-oriented programming languages. With the release of ES6, some new syntax concepts came out that allows us to do this in a more traditional approach. The more traditional approach being that I would use a class for the animal, and then where I initialize the weight and speed would be in a constructor. So I want to go ahead and modify this so that kind of our existing code that we have, where we're creating an instance of an animal and setting the description, we still want to be able to do that, but we want to do that with modern ES6 syntax. So I want to create a class called animal. And now I don't have beginning and ending parentheses. I'm going to begin and end the class with curly braces. Each class is going to have a constructor, and my constructor is going to take my weight in miles per hour. And then I'm going to be able to initialize the weight and speed, so I'm going to copy and paste that information. So there's my constructor. Now I have an explicit constructor, and then the description is going to be a function definition that's inside my class definition. So I'm just going to have a description that returns the same information that I had before. Okay, so it's a little bit different in terms of how it's coded, kind of a more traditional approach. The one thing I would point out is that in Java, a function, whether it's defined inside the class or outside the class, looks pretty much the same. In JavaScript, that's not the case. You'll notice that I just have the name description, and it automatically gets attached to the instances of my animal. So I have a description with beginning and ending parentheses. I could have parameters here, but I don't define it as a function. You'll notice the function keyword doesn't show up there. It just is a function. And then when I come over to my browser, you'll notice that it's still working the exact same way. Now we're using modern ES6 syntax to create my class definition. Okay? I would argue that the description is really not a function. The description's more of a property. So I'm going to modify what we have. So keep in mind, if I want to add functions like, maybe animals get a drink or eat or whatever they do. So I want to add functions, I can add them with this syntax. However, I'd argue that the description's more of a property, a calculated property of an animal. So what I'm going to do is I'm going to make it a getter. So we have traditional getters and setters. I'm going to make this a getter. So I'm going to get the description. And because I make it a getter, then it's no longer a function up above. It's going to be a property where I don't need parentheses. Okay, and then the idea here is that I'd still end up with the exact same thing, and I'm running into a problem with my description. Interesting. So get description. Complaining about, I'm missing a parenthesis in my console.log statement. Okay, so you'll notice that my getter works just fine. Whether I'm using it as a function or as a property, getter and setter, things work great. The only issue with the getter is the getter cannot take parameters. Okay, so no incoming parameters. The setter takes one incoming parameter, so I'm assigning a value to a corresponding property. So that's pretty traditional, but it's not necessarily intuitive from the syntax here. Okay, the next concept that I want to look at is the idea of inheritance. So I have an animal, and now I want to have a specific type of animal. And in our case, the specific type of animal that I want to have is a penguin. So I'm going to have another class called penguin, and I want it to extend the animal class. And our penguins are going to have one attribute, which is has feathers. Okay, so one attribute called has feathers, and I want that to happen in the constructor. So I'm going to have a constructor for my penguin. I'm going to have an attribute that gets passed in, which is feathers, and I'm going to say this dot feathers is equal to whether or not this penguin has feathers. In addition to the fact that I need to know if a penguin has feathers, I'm saying a penguin is an animal, so if it's an animal, then I need to know the weight and its speed. So I'm going to go ahead and pass that information in as well. So weight, speed, and then a penguin is a specialized type of animal. I want to know if that penguin has feathers. Okay, so I get the weight and the speed. I don't want to just assign weight and speed to the current instance of the penguin. A penguin is an animal, so we already have the attributes weight and speed coming from the fact that the penguin is an animal. So I want the animal to have the weight and the speed, but our penguin is going to have the unique attribute of feathers. In order to make that happen, I have to call the parent class constructor. So I want to create an instance of an animal. I'm going to call the parent class constructor using the super convention. The parent class constructor used a weight and a miles per hour. So I'm going to use a weight in miles per hour. I'm going to forward that information along to the parent class constructor. And then life is good. I should be able to create an instance of a penguin. Okay, so if my penguin does nothing else other than just create this instance, that's fine. I should be able to now create an instance of a penguin. Okay, so let Sparky equal a new instance of a penguin. And when I create an instance of a penguin, I need information about the penguin. So I'm going to say that the penguin is 15 pounds, can run 15 miles per hour, and does not have feathers. Sparky doesn't anyway. And then I'm going to log Sparky's description. Okay, so I head back over to my browser, I refresh the page, and I get an error, miles per hour is not defined. I screwed up. I have to pass along speed instead of miles per hour. Now I refresh this, and now you'll notice that even though I'm creating an instance of a penguin, because the penguin is an animal, it will inherit the description, and I get the description indicating the weight and the speed for a penguin. The description doesn't have any information about feathers or anything like that. I could certainly override the description in the penguin class, but I chose not to. Okay, so then the next concept I want to cover is the idea of static variables. So static variables are class level variables, and by class level variables I mean these are variables that are associated with the class as opposed to any particular instance of the class. So let's say I wanted to keep track of how many animals we have. Okay, so the logical place to do that is in the animal class because we're keeping track of how many animals. So what I want to do is I want to have a variable that's going to keep track of how many animals we have. Okay, one thing I want to point out is if I have this animal count, I do not want to initialize it in the constructor. Okay, I don't want to initialize the animal count to 0 in the constructor, and the reason why is my animal count is supposed to be keeping track of how many total animals we actually have. And in this case, if I'm going to reset the animal count to 0 every time an animal is created, then that's not really achieving the goal that I want. Okay, so I want to make sure that I'm initializing that variable where it's declared. So I initialize it to 0. And then what I want to do is I want to increment that animal count every time my constructor's called. Okay, so if I have a variable inside my class, a lot of times I'll use this syntax, this.animalCount plus plus. So I might want to increment it. In this case, because it's a static variable, that'd be the incorrect approach. And just to kind of talk about that for a second, the static variable is not attached to an instance of an animal. This would refer to the current instance of an animal, the one that's getting created. That current instance doesn't have an animal count, and that's not the intention of that static variable. The static variable is tied to the overall class, not to any particular instance of an animal. So instead of using that particular instance of an animal, I'm going to use the animal class to reference that variable. Okay, and then every time I do that increment, so I'm going to increment the animal count, I'm going to log the animal count. So we can see how many animals we have. So we should see the animal count going from 0 to 1, 1 to 2, and then 2 to 3. So we should have exactly 3 animals. And just so that we have some clarity, I'm going to go ahead and have a label. Okay, so I have a label indicating what the animal count is, and now if we come back over, you'll see the animal count is 1, then it's 2, then it finally gets to 3, and we have exactly 3 animals. So that animal count is tied to the overall class as opposed to any individual instances of an animal. Okay, so we have static variables to go along with our existing variables. Okay. Another thing that I want to cover is the idea of, well, let's actually expand on this static variable thing a little bit. I can also have static methods that are attached to the class, and I don't necessarily want to go through a demo of this for my animal class because I don't think I have a good example that would make sense. But where this would come up is we've been dealing with arrays a little bit in this class, and arrays use some static variables. So one instance of using a static variable is, let's say I wanted to create an array from some kind of list. So let's say I wanted to create my grocery list. And the way I'm going to create the grocery list is there's a million ways to do this, right? I could use square bracket notation, or I could say I want a new array. But the way I'm going to do it is I'm going to use a static method. So I'm going to say I want an array of these items. So candy, and chips, and soda. And then if I just do a console.log of my grocery list, we should see that I have an array. Okay, so then I have an array of 3 items, and what's happening here is this of method, you'll notice I'm calling it on the array class. I don't have an instance of an array. I'm saying, okay, given this array class, I know there's a method, and that method is called of. It's a static method that will allow me to create an instance of an array based on the data that I pass into the of method. Okay, so that's an instance of a static method, so a class that has a static method. Okay, so we can have static variables, we can have static methods where they make sense, but the idea with the static is that those static variables and methods are attached to the class, not to instances of the class. Okay, the last topic I want to cover with object-oriented programming in JavaScript is the idea of extending existing classes. So for instance, let's say I wanted to create my own customized array class, and my customized array class was to store my animals. Okay, so I want to create something that's going to be a container for animals, so I'm going to call my class zoo. So I'm going to have a zoo class that extends not one of my classes, but it extends the array class that's built into JavaScript. Okay, so the zoo is an array, but then I can add additional features into the array. So for instance, I might want to keep track of what's the name of the zoo and what collection of animals are in the zoo. Okay, so in our case, we have a giraffe, we have a dog, we have a penguin. So I want those 3 animals to belong to my zoo. So I want to use the fact that a zoo is an array to store the data, to store my animals, but then I also want to extend it. I want to give the zoo a name. So normally arrays don't have names, but my zoo should have a name. So I'm going to have a constructor for my zoo, and it's going to take a name. And then I want to take a collection of animals. So I'm going to use the rest operator to take in any number of animals. So from 0 to n number of animals in the array. Okay, so we know that since it's a zoo, I'm going to create a property called name that's going to have the name that's passed in. But then I have to deal with this collection of animals. And this collection of animals, so I'm going to create a zoo saying here's the animals in the zoo, is going to come into this constructor as an array. That's because I'm using the rest operator. So what I want to do is I want to take that collection of animals and actually store them in the array. So I can't say, this.animals. That doesn't make sense. I want to use the fact that a zoo is an array to store these animals. So the way I'm going to do that is I'm going to take the superclass, the array, and I'm going to call its constructor. And I'm going to call its constructor passing in the collection of animals. So I can't just pass in animals because that'll pass in an array, and then the array will have one element, which is an array of animals, which I don't want that to happen. I want each individual cell within the array to store one animal. So what I'm going to do is I'm going to spread the animals into a new array. Okay? And then the idea is what I want to do is I want to be able to just get a description of the zoo. Okay, so I'm going to have a get description where I return this. So really simple. Okay, so nothing really going on. I add one attribute to the array class where I return the current instance, the zoo. The zoo should store all the animals, plus it should have this additional information about what the name of the zoo is. Okay, so I want to create an instance of a zoo. So I'm going to create a new zoo, and the new zoo has a name, so Henry Vilas Zoo. And then I want to send in all the animals that we have. So I'm going to send in my giraffe, I'm going to send in my dog, I'm going to send in my penguin, Sparky. And then I should be able to log the Vilas Zoo. Okay, so we go back over to our browser, I refresh the page, and you can see I have a zoo that has 3 elements in it. It has an animal, a penguin, and then it has this name, Henry Vilas Zoo. So you can see, like if I actually look at it, index 0 is an animal, index 1 is an animal, index 2 is a penguin, and then in addition to those 3 indices, we also have the name, which is Henry Vilas Zoo. You can also see that the prototypal object, so inheritance, this prototypal object, inheritance is still achieved through the prototype, and the prototypal object is that array. Okay, so then what I want to do is I have this Vilas Zoo, and I might want to be able to iterate over the zoo and print out all of the corresponding animals and their descriptions. So I want to give the weight and their speed for each animal in the zoo. So traditionally I might use a for loop to do that. So with modern ES6 there's 2 different types of for loops, and one works better than the other. One works really good for iterating over collections, and one for loop works well for iterating over objects. And this gets a little bit confusing because arrays in JavaScript are just objects. So let's look at it both ways. So if I say for, and then I'm going to have for in loop for animal in Violet Zoo. If I do a console.log of the animal description, okay, what will end up happening is I refresh the page and you'll notice that I get undefined 4 times. Okay, so it's not working the way I'd expect it to. So it's happening 4 times even though there's only 3 animals. So I'm trying to get each animal and then I'm trying to call the description. It's happening 4 times. It's happening once for animal, twice, the second time for animal, third time for penguin, and then the 4th time for name. And I really don't want to iterate over the name if I'm iterating through my collection. So the way I would change this is instead of for animal in Violet Zoo, I would say for animal of Violet Zoo. So I save that and I head back over to my browser, and now you'll notice that I'm not iterating over 4 elements, I'm just iterating over the 3 elements, the 3 animals that are in the collection. Okay. Okay, so then let's add a couple of more animals, and I want to show you a couple of cool array methods that we might use. Let's just add dogs. Okay, dogs are easy to add, so dog 1, 2, and 3 will weigh 150 and can only run 25 miles an hour. And then dog 2 will weigh 80 and can run 30 miles an hour. And then dog 3 will weigh 10 pounds and can go 35 miles an hour. Okay, I don't know if that's realistic or not. What I want to do is I want to add those to the zoo. So dog 1, dog 2, dog 3. So now our zoo is getting more populated. If we go back over to our browser, we can see that that's getting more populated. Okay, things are good there. So our zoo now has a collection of animals. It looks like we have, 6 animals in our zoo now. And what I want to do is I want to have a method that will give me the heaviest animals in the zoo. Okay, so I'm going to have a method called heaviest, and the heaviest will return the heaviest animals. So I just want to sort this. Okay, the way the sort method works is if I take the collection, so I take the array, and I call the sort method. The sort method takes a function that compares 2 animals and then tells me which one's heavier or lighter. Depending on how I want to sort that, I'll return 0 or 1 or -1, depending on my sort criteria. So in this example, I want to take in 2 animals, so animal 1 and animal 2, and I want to send those into a function definition. In my function definition, what I want to do is I want to return, is animal 1 dot weight greater than animal 2 dot weight, and I'm going to use the ternary operator here. So if that's the case, the true part will be 1 or -1. Okay, that's my return value when I'm asking for the heaviest. So now, if I want, this is going to return all of my array, and it's going to sort it. So what I want to do is I want to take the zoo, and I want just the heaviest animals. So I want them sorted by heaviest. So I'm going to do a console.table of my Violet Zoo .heaviest. Okay, and that'll be the last thing that you see, and you'll notice I'm getting undefined here. That's not good, because I'm not returning anything here, so I want to return the sorted collection. Okay, and then you'll notice that I'm going from lightest to heaviest. Well, I probably want this exactly the opposite. So what I'm really checking is animal 1's weight less than animal 2's weight, and now you'll notice that the sort order changes exactly the opposite. So now I'm going heaviest to lightest. Let's say I wanted to change the problem. So I want the problem, well, before we change the problem, let's refactor this code a little bit. Because the only thing that's going on in this sort function, so the sort is getting passed a function comparing two animals' weights, because the only thing that's happening here is I'm returning the result of that. It's either 1 or -1. I can use the fact that that's the only thing that's happening, that's the only line of code, and I can use the fact that I'm going to get an implicit return. So what I can do is I can get rid of these curly braces in the return statement, and then I can rely on the implicit return to return that sorted array. So I get to refactor it a little bit, so it's a little bit cleaner, and then I end up with the same result. Okay, so I'm still sorting the array. Now I want to change the problem so that I might only want, the 3 heaviest animals. Okay, so I want to be able to take a parameter that says here's the 3 heaviest animals in the zoo. So now my heaviest is going to take a limit that I'm going to default to 10. Okay, so I default the limit to 10, but in this case I'm going to pass in the value 3. So I use that limit, and I only want to take the top 3, but if you don't pass in a parameter, then I'm going to take the top 10. So I want to take that into account. So I sort the list, heaviest to lightest, and then I want to splice the array from 0 to my limit. Okay, so now whatever my limit is, in our case it's 3, I should only get the 3 heaviest animals. Okay, if I don't pass in a limit, then I don't have to splice out anything, and I get all of my heaviest animals. Okay, so I can splice out just the amount that I want. So where this comes into play is maybe I want to create a class definition for user reviews, and I'll extend the array. So I'll store all the user reviews in an array, and then each user review is going to have a rating. I might want to be able to sort by rating, and then I might only want to display 10 ratings at a time. So I want the highest rated movies, or the highest rated books, or the highest rated whatever. Okay, I can use this to sort my collection and then filter it out so that I can do paging, kind of like our Google search results, where we have a billion search results, but we show the top 10, the next 10, the next 10. We can use this splice method to limit our results. Okay, so ES6 introduces the concept of classes. It introduces the concept of constructors. It introduces the concept of inheritance. But my guess is you're familiar with all of this stuff from other object-oriented programming languages. So the syntax should be fairly familiar to you. So really all that happened with JavaScript was some of the modern syntax that you're used to from your Java, your C#, your C-style languages has now been integrated into JavaScript, while JavaScript under the covers is still just using prototypal inheritance. So you saw that when we were logging our penguin, you could see that the penguin's prototype animal is just a generic animal. You could see that the zoo's prototypal object is an array. So we get inheritance from prototypal inheritance.